Hello guys and welcome. In this lecture we'll talk about the image pyramids and how we can use them in OpenCV. First let me create a Python file. I will call it image pyramids.py. So first let me show you how the image pyramids are, and for example if we have an image like this image here as the original image, and when we take the half resolution of this image or take the half of this image using blurring and subsampling method and continue this process, we will get like a pyramid, so like this image here. So this is why this type of process is called pyramids, because we have an image and at each time we take the half of the resulted image and so on till we get the desired resolution. Let's see it in practice with OpenCV. First I will import CV2 and numpy. So I can read an image from this data folder here. So if I read an image like that, cv2.imread, you can read any image, and I will read for example this image. And if I come here and say cv2.imshow original image and call it here this image and saying cv2.weight key 0. Let me show this image, Python, and then Python and saying image pyramids.py, and as you can see this is the image that we will work on. Let me create a copy of this image. So if I call a copy of this image as A and saying image.copy to change this image and not affecting this original image. So the first type of image pyramids is which called the Gaussian pyramids. Gaussian pyramids and pyramids. And the idea of this type of pyramids is just like this one. Each time we blur and subsample the image. However, another type of pyramids is called the Laplacian Pyramids, and this is the opposite of this method. When we have a small image and at each time we take the bigger image, or we multiply the resolution of the resulted image by 2. So this is the opposite of the Gaussian pyramids. We'll start by the Gaussian pyramids. So if we take this image A and taking for example A1, which is the first layer or the first level of resolution, so in this time we'll take the level 1 by saying cv2.pyramids.down and then giving it the A image. So if I print here the shape of this A image and printing here this dot shape I want, and the same also here but for A1 shape, and if I come here and saying cv2.imshow, this is, let's say, call it layer 1 or A1 for simplicity, and calling here the image A1. So if I show the image here, Python image pyramids.py, as you can see this is the half of this image. So we have here the original image and the first layer of Gaussian pyramids, which is the half of this image in the height and also in the width. As you can see this is the half also in the width, and the shapes also here. So this is the shape of the original image and this is the shape of the first layer of the Gaussian pyramids. Let's do it for many layers. So if I take for example A2, which is cv2.pyramid down of A1, and do it, for example, a3 also 3 times cv2.py pyramid down of I2, and a4 cv2.pyramids of down of a3. So this is 4 layers here, and if I show them here by saying cv2.initial, call this a2 and call it here a2. Let me copy this one like that, and saying here a3, a4. We may take also a5, for example, cv2.py down a4, and if I want I can show here, for example, if you want you can show a5.shape like that, and if I can say a5, a5, 4, 3 and a2. Let me show this here. So this is the original image, and this is the first level or first layer of this pyramids. The a2 here, I have it here, so if I can put it here for simplicity. This is the original. This is a4, I have here a3 and a5. It's very small image. So as you can see, this is the original image, the first level of first layer, the second one, the third one here, and the fourth one here, and this is the fifth one. And also the shape here, so this is the shape of the last, this fifth image here, the last one. So this is how the Gaussian pyramids working, and next we'll see the Laplacian pyramids and how they are working. Before go to the Laplacian pyramids, let me show the this for another type of image. So for example, if I take the image of apple, for example, and show it here, so this original image, the first layer, the second one, the third one here, can make this small, size the window here, and the fourth one here, show it, and the fifth one here. And as you can see here, the resolution here is also changed. So now we have seen the pyramid down, and let's see its opposite, which is pyramid up. So if I come here and saying a5 up, so I will just use U as for short, and I will say cv2.pyramid up, and I will give it this last image a5, and let's do it for the other images, so like that. So let's call this a4 up and a3 up and a2 up, and also for a1 up. I will change this to a4, and here 3, here 2 and 1. I think I copied this 2 times, so this before 3, 2 and 1, and we don't need this. So this is just the opposite one of this one. If I come here and saying print a1 up dot shape, and if I change this to, for example, a1 up and a2 up and a3 up, and also for 4 and for 5. And let me show them here, Python image pyramids.py, and as you can see, this is the a1, just looking like the original image, so as you can see here, and the a2 here, this is their ups, so we get here A5 and A3 as you can see, and we get the original resolution like that. Of course this image is not the same, if you look at it, it's not the same as the original, but have the same resolution and it looks like the original, even if there are some modifications due to the changes like the sampling, for example, the upsampling, the downsampling, and also the blurring and sharpening that these methods did during the change from one resolution to another, or from one level to another level. So now for the Laplacian pyramids, the process is a little bit complicated. So let me comment these out, I don't need them, and this also. And if I create three, for example, for three layers, so for example if I say for I in range of 3, then I will, if I come here and create also Gaussians, so for the Gaussians I will create a list that contains this A as an image. So if I come here and say Gaussian is equals to cv2.pyrDown and give it, for example, giving it this A, and if I call this also A, so then I will come here and saying Gaussians dot append this A, and at each time we will add the results that we get after we doing this pyramid down. So now for getting the Laplacian, I will want to comment this also. So if I come here and saying the top Laplacian, and this will be the last one here, the last Gaussians. So this Gaussians minus 1, which is the last one in this list. And now I will create a list for I in range of, I will go from 3 to 0 with a step of -1, and I will come here and create a variable called size, and this will be the shape of the Gaussians of I minus 1 dot shape 1 and Gaussians I minus 1 dot shape 0, and then we will create an expanded Gaussian. So expanded Gaussian will be the cv2 dot pyramid up of the Gaussian of I, and with destination size that take this size, because sometimes we have an image, we may have an image that when we divide it by 2 we get resolution that contains, like, for example, decimal points or decimal number. So we need to the OpenCV convert it to integer. For that it may round it to its lower number or higher number, and in that case we will get different resolution or different shape. So we need the output image to have the same shape as this Gaussian image that we give it here. Now we need to create the Laplacian image, so I will call it, for example, up, and it will be cv2 dot subtract this Gaussian I minus 1 with this expanded Gaussian. And if I come here and create a list of the Laplacians, and I will give it this top Laplacian. This is the last image of the Gaussians, and then I come here and saying Laplacians dot append this Laplacian. so it is actually lap like that, and let's come here and saying Laplacian. So now we can show these Laplacians here. If I come here and saying cv2.imShow layer 1 and giving it the Laplacian with the index 3, the last index, and then cv2.imShow layer 2 with the Laplacian index 2, and then cv2.imShow layer 3 with Laplacians with index 1. So let me show them here. Python image pyramids.py image, as you can see here. So we have here the 3 layers of Laplacian pyramids. It looks like black images, but actually, because this image is not the best one to show the Laplacian pyramids, let's see it on another image. So if I come here and see it on another image, for example this image, and if I run the code here like that, so this is the first layer of Laplacian pyramids, and the second one, and this is the third one, and we will see it in practice, and we'll do a project with these pyramids in the next lecture. And let's show it also in another image. So if I, for example, call it the messy image like that, and if I run the code, so as you can see, the second layer, the first layer, and here is the third layer. You can do many other layers if you want. I just did here 3 layers, and in the next lecture we will see it in practice. We'll do a project using this image pyramids. So see you in the next lecture.